So we started off with understanding how this graphical system design platform really helps accelerate the development, right? At National Instruments, like John and Sujit mentioned, we continuously keep improvising our products. There is close to 16% of our revenue which goes back into R&D to come out with new products to help make all of these design processes a lot faster. So here I'm going to introduce to you some of the embedded products that we have launched in the recent past, which really helps people to get closer to their solution much faster. I'm going to start with the same application that I spoke to you about, inverters. We saw the single board Rio, which is a stripped down version of the compact Rio, which is used for building different embedded systems. So here is an add-on board, an I/O board, which has been built, which we call as the general purpose inverter control board, which has the required direct connectivity to analog current and voltages. It also has direct drive capability for driving those high-speed switching systems, be it IGBTs or be it MOSFETs. So this is one board which has been very, very well received by a lot of these smart grid and the solar power enthusiasts. And we're very happy to bring this to India as well so that we can help solve some really amazing applications with this general purpose inverter control board. So to add to this, if you have to make these inverters grid ready, it also is important that this inverter forms a part of the existing ecosystem, which means it's able to communicate with other devices. So we've come out with an electrical power suite which can quickly help you implement protocols like DNP3 or 6850 onto the same platform. So thereby, being able to do measurement control and at the same time being able to communicate with the existing devices is made a lot easier. Moving on, I'm just going to take a couple of seconds to tell you that this product has been used by one of our customers in the US, Dynapower Corporation, to really build inverters much, much easily. So they typically, in the traditional approach, used to take 72 weeks to develop the inverters. With the introduction of the LabVIEW design tools and the GPIC, they've been able to bring it to less than 1/3, which is an amazing feat when it comes to being able to develop and deploy these systems much faster. So moving forward, there is a multifunction I/O board, which comes as an integrated part of the single board Rio. So that's another new addition. It's a very small form factor. It can be used in different solutions that you're trying to build, and it can go in as an OEM product, so you don't really have to go about developing these boards from scratch. So you have the IOs, the processing, all integrated into one board. You could just put it onto a machine and move forward in deploying them. There are more additions that have been done to the compact Rio platform to be able to expand to a larger number of IOs. There is a Mixi Rio which has come up. The Mixi Rio basically provides the same IOs that you have on compact Rio onto the PC. So in terms of prototyping, this would be a really amazing platform. We also have an Ethernet version of the same so that you can run long wires and have remote IOs talk to your units as well. To make the evaluation much easier, we have come out with the LabVIEW Rio Eval Kit, which has a single board Rio and some peripherals which you can quickly put together and get started on your embedded systems. This is an interesting thing. National Instruments acquired this company called as Driven, and Driven has been very extensively working on prototyping of engine control units or electronic control units for automobiles. These are modules that fit onto the same compact Rio platform, the modular FPGA-based platform that you saw. And these I/O modules help you directly interface with automotive sensors, be it the H-bridge throttle control feedback system or the oxygen sensor, or for that matter, to even the fuel injection unit, right? So this is an amazing platform which can help people put together engine control units and be able to prototype it. I think 4 years ago, showed a demo of this, or rather a demo video of this, where Yamaha had this sitting behind one of their bikes doing the engine control. Now, people who are interested in building their own engine control units can quickly use these NI products and get started with them. So that was from the embedded side. Now, the embedded systems, if you look at it, is becoming complex with all these great algorithms, the abstracted algorithms going into them. There is a lot of intellectual property that goes into them as well. In the example that John mentioned, when it comes to eye cataract surgeries, there is requirement of being able to put that optical coherence tomography algorithm onto the FPGA. So those are some amazing IPs that people have built. Now, if you're using these in your systems that are designed, it is important that you should be able to test these systems with some things that are equivalent. Now, if you depend on a third-party vendor to provide you a test instrument to test it, I'm pretty confident that you will not be able to test the full functionality of it. So to be able to test the complete functionality of these complex systems that you build, it is important that you are able to leverage a platform which helps you do the testing the way it was built, right? So in that direction, there are some really interesting directions that we see from the market. People are doing hardware-in-loop testing. People are also doing protocol-aware testing of most of these newer standards that are coming up. So from that point of view, we see that our direction of software-defined instrument is really getting a lot of traction. So to give you a little bit of insight about what we are doing in the test and measurement world, I'm going to start with the history. Way back in 1920s, General Electric or General Radio came out vacuum tube-based instruments. As time moved on, as transistors came into picture, Hewlett-Packard came with instruments which were built using transistors. And today, National Instruments leads the way by saying software is the instrument, or define the functionality of your instrument in software, right? So that is the paradigm that we are trying to bring in. And in terms of the capability of the software, it is pretty vast. You saw how an embedded system can be developed, and the same software can be used to build your test system as well. But the hardware really needs to scale up to be able to deliver the required results. When we talk about performance or when we talk about test time reduction, it is really the platform that helps you scale up your performance. So that's PXI that you see here. PXI is an industry standard and has been well adopted in the industry for test and measurement. So let me quickly take you through what the PXI platform is. PXI stands for PCI Extension for Instrumentation. There is a complete computer sitting inside the PXI chassis in the first slot of it. And then there is a backplane which helps you connect to multiple instruments or multiple hardwares which can be plugged into different slots. Now, there is a very, very tight synchronization that can be done between multiple of these boards to ensure that you're able to test the latest technologies that you are coming out with. So synchronization, and there is also a bus which connects all these boards to the controller, and that is also based on the commercially off-the-shelf technologies. Now, why do we harp so much on commercially available technologies? The reason is these technologies are being heavily invested on, and they are bound to follow the Moore's law, which is doubling the processing power every 6 months. Now, imagine if your test system has better performance every six months. Is that not going to help your oscilloscopes? But digitizers can be used for doing any type of measurement. You could do spectrum analysis. You just have to bring the signal, and the software defines the functionality. Then we have multimeters. We have DC source measure units. So there are a variety of these instruments that National Instruments has, and that's how we have 500 plus of these PXI modular instruments, as we may call them. And this has been acknowledged by just not our customers, but our competition and the neutral bodies in saying that National Instruments leads the way in the PXI instrumentation. So we're thankful for all of you for having been a part of this venture in making this software-defined instrumentation the mainstream of test and measurement. So PXI as a product is a very versatile platform and can be used in multiple different application areas. To start off with, we can use it in aerospace, defense, like Sujit spoke about some of the application. It could be used in the biomedical instrumentation or the biomedical embedded system testing, like John had mentioned. We have energy, we have communication system design, we have semiconductor, and a whole lot more. Now, to be able to take you through some of these application areas, it's a great pleasure for me to welcome Mr. Chander from TCS. He's the head of Embedded and Consumer Electronics Group. And I'm also happy to welcome Tarun, who's our Business Development Manager for RF and Modular Instrument. Welcome, join us on the stage, sir.
Thank you.
Thank you so much for joining us.
Thank you, Satish.
And let me request Mr. Chander to lead the discussion on how he's been able to use our products in the consumer electronics industry that he serves.
Oh, thank you very much, Satish. It's a privilege to be here on this podium to share some of the values that we see from NI and how it has benefited us and how it has benefited our customers. So before I jump into what is that I want to present here, and I would like to share the challenges that the market had and the motivation for us to get into this type of a scenario to partner with NI and come out with an innovative thing.
Sure.
See, the challenge, I think all of us are, in a daily life we have seen phones becoming smarter, TVs becoming more smart. I think there is nothing to say, even the testing has to be smart. So with that saying, I want you to look at the current challenges what the embedded industry is currently facing. I think it's very traditional that the requirements are told upfront to you, and we very clearly have understanding what features have to come. And if you look at a market like a consumer market, basically it's a huge market and the expectations keeps changing regularly. How do we address these challenges? The traditional way is you have a requirement, make the code out of it, you have traditional tools which comes from a lot of people, try to integrate into the system, and after you develop, then you go for a testing cycle and then you launch the product. I think those days are gone by. The agile has come in, and that's where we see a lot of value and lot of value that we need to present to the people in terms of cost, in terms of the product launch is actually the drive factor for us to really think in a different way. For example, one of the challenges that we had was the requirements was given to us. It was about 8 to 9 months earlier. So we were very confident because we knew the whole stuff and we knew what are all the systems that we need to look for and how are we going to use the systems in the whole process, and we built the product. So the development team kick-started it, and the testing team was on its own way, deriving test cases, formulating test scripts and doing it. But then came the real challenge. The customer told us, now the feature what is there, I think we need to change. There is a need for a change because the market is expecting a change, otherwise this product will not survive, it will reach end of life. So what is that? In traditional mode is, again go back to the drawing board like what you mentioned earlier, again architect the whole product from beginning and then come back with a way how you want to do it. And that is the problem and that is the challenge that I personally faced when I started working for my customer. When I started interfacing with a lot of people, I found NI as one of the most value partner which really provided me a value. Here he comes with a modular design. I think that is where it really helped me to look at a modular design or a modular card. Basically, if you take a test setup, we have a bench on which you can start inserting a lot of PXI cards into that. So thereby, these cards act as enhancement of the product that is going to be created. So you already have a benchmark or a base system on which the product or the software maturity can go in line with the test and measurement maturity. I think that is the point which I would like to emphasize here. If not for the test framework and the test bench which had that module, which was the feature what the customer was looking, the project would have been closed. I think that was one of the key differentiator factors what was helping. Having told that, it is not only from that perspective that we insert the card and then the challenge is over. The next step comes, how are you integrating the software that you are developing and how are you ensuring that you are harnessing the complete power of the card that is going to get inserted into the test framework what we are having. That's where I think Sujit and team and the rest of the NI technical folks help the team completely translating into a very vague requirements into a more standard based requirements. And we are very proud to tell that this requirement, which was very vague initially, translated into a very clear documented requirement with a very clear set or test setup scenario, which helped us to roll the product in time. I think this was one of the key challenges. Thanks NI for doing all that, and I think that was more an innovative way of creating or solving a problem which everybody faces in our day-to-day world.
Sure.
That is what I felt I should share on stage here. What is that we wanted to do. And in addition to that, we are also thinking like to give some value to our people and to see how we can leverage the instruments or the products that we are having. How do we enhance and enrich the complete power of the whole system that we are putting in place? Typically, I represent the consumer electronics of the the group. So obviously the requirements are very vague, and every product has to be delivered tomorrow type of kind. So you don't have anything that has to be done. So you have to be proactive in planning what is needed for the future and upfront be ready what has to be delivered. And it is not like I will make it and then I will do the testing. That is not going to fly, because all the consumer demands are all tied to milestones. If you look at India, it is during the Christmas season or during the Diwali season the products are going to be launched. If you miss that market, you have another 12 months to wait. So I think that is where I think all of us are having the same problem, and I think most of you would be experiencing. And I see value where the products or the measure instruments which comes from NI is really helping us to accelerate or recover some of the losses that could have happened if not for involving with a partner which has got a modular design which can get seamlessly integrated into the development chain. Yes, sir.
Sure.
So what I want to also share here is we have a success story what we have showed to some of our customers, and how did we leverage the return on investment, because anything that you want to do on testing, obviously you have to think for yourself, why do you invest on such a huge thing and how you can leverage. So typically I think what we are trying to put here is we are assuming a set of some 500 to 1000 test cases that has to be tested, and in the current scenario it is being manually tested, right? And now I am thinking of how do I automate that stuff. The need for automation is twofold. One is to ensure that I am removing the people dependency from the whole chain. Second thing is, if I am remotely working and if my people are sitting in the different geography, if I want to harness the time zone advantage, I would like to see how I can use it to my advantage. So what happens here in the system is we would like to have a system irrespective of the geo, irrespective of the people, just a click of a button you should be able to do a complete testing, and that should result in a feedback to the development team for you to fix the bugs. So this example or an illustration what I am showing here is for about 500 to 600 test cases that we took, and traditionally it takes about 5 people to do this testing over a period of 1 week. And believe me, with a conservative number of $30 if you put per hour for testing, it would cost somewhere around 150K or something for doing this testing. So now how do I do it differently? So can I upfront invest on something which is available so that I can leverage this tool and make it more or less independent of all the variations whatever is going to be in the system. So that is what we did, and here you see a graph where you are giving a return on investment. If you see that the first year basically the return on investment is negative. The reason is because if you have to automate, you have to invest. If you have to invest, it is cost. So that cost has to get absorbed in the system. So as you start moving forward, as you start energizing the automation flavor into the system, the advantage of automation comes into play, and you can see the return of investment coming from second year, which is 3%. I am taking very marginal numbers here, and then you can see the scale at it. It reaches 43%, 42% in the third year, 75% in the fourth year, and almost about 105% in the fifth year. So this is a tremendous change from what you invested to what you are going to get as a gain. Believe me, I have taken only one variation of the product in this whole cycle. If you look at consumer as a product, the same testing can be applied to the family of products, or it can be applied to the generation of the products. Just to give an example, if this is a case of a UI testing of a multimedia product, the same testing can also be applied on a telecom world. The same technology can be applied in an aerospace world or an automotive world. So if the company which is going to invest is very diverse, and if they start investing in these tools, and if NI is coming out with modular things which can get integrated in the system, I think we are all set to deliver what is needed for the market at least for the next 3-4 years. So this is a realistic example that I am bringing on table to show to you how early investment and how collaboratively working in early stages with a company like NI gives you an advantage on the return on the investment that you make upfront. So I am very proud to share these numbers with all of you, and I want to thank Satish and the entire team of NI and Sujit for helping us to achieve this. My customer is completely delighted about this, and he's gone about placing number of orders to ensure that for his roadmap for the next 10 years is completely secure. So I can vouch for it, and I would like to also give final round of appreciation for Satish and team for doing it.
Thank you so much, sir.
Satish.
It was great having you, and let me request you to quickly unveil the next generation of instrumentation with your own hands. Please,
Thank you,
please join us here, and